Alright, hi y'all. Today we're going to be going over ordinary differential equations that we might see in the FE exam here. We're still in the mathematics portion, so of course not only ECE is going to be getting these questions, everyone will be up for grabs on these questions. So the first question here is we have a first order linear non-homogeneous differential equation, and the function here is dy dt plus 5y is equal to 10. We're solving for the general, or actually it looks like a particular solution, y of t, and they give us the initial condition of 0, and it's giving us 2. So that is what's called a particular solution. This is a particular solution question. The way you can figure this out is because they give you an initial condition. Usually you're just solving for the general solution, but if they give you a point, you should be able to solve for the constant of integration c that is going to depend on this initial value. So now the way we get this here, the way we solve this is we have to solve for p of t, which is 5, is going to be this value multiplied by y, and q of t is equal to be 10, is going to be equal to that value. Okay, so thankfully it's already in the form, but sometimes you won't get it so nicely in that form. You'll just have to rewrite it into this form. Okay, so now we have to do this thing called I think it's called like the integration factor, where we want to solve for h of t, which is the integral of p of t dt. And we can replace p of t with 5, and we know the integral of 5 with respect to t is 5t. Okay, and now we want to do e to the power of h of t. This is going to be e to the power of 5t. Okay, and this is our integration factor. So now what we want to do is we want to take the integral of e to the 5t, which is e to the h of t, times y, and we want to take the derivative of it. Of course, I'm not going to go into detail about how I derived this equation. I remember this in engineering math. And if you have notes from then, we've definitely done very many questions like this. I think there were like 3 or 4 homeworks over this topic actually. But then we set this equal to the integral of e to the h of t times q of t dt, of course. And we know this is e to the 5t. We know this is 10. So what is this going to be? The integral over derivative is just the function on the inside. And we know this is going to be equal to the integral of e to the 5t times 10. The only thing that's going to be integrated is e to the 5t. The integral of e to the 5t is 1 over 5 e to the 5t. So what we have is 10 over 5 e to the 5t plus c. We cannot forget this plus c. That's our constant of integration. And now we know this becomes a 2, but we want to find y of t, not e to the 5t y, or y of t. So we divide by e to the power of 5t, which is now going to be y of t is equal to 2 e to the 5t divided by e to the 5t is 1, plus ce to the minus 5t, because we divide by e to the 5t. Now this is where we have to be careful. We have to plug in our this initial value here. So y of 0, well, we know this is going to be equal to 2 given by the question, and we set this equal to 2 plus ce to the minus 5 times 0 because we're plugging in t, or 0 for t. This becomes a 1, therefore 2 is equal to 2 plus c, therefore c is equal to 0. It just has to be. So we know c is equal to 0, meaning this equation is telling us that y of t is equal to 2. And that is going to be our particular solution for this problem. All right, so now we go on to the next question, a second order differential equation. And it says it's underdamped. What does that mean? Well, we're going to get to that part later. But right now, what we have to do is solve for the roots. We replace y double prime with r squared, and we replace y prime with r. The y by itself is going to be a constant. It's going to be equal to 0. Now we find the solutions, or the roots, or zeros, for this quadratic formula, or quadratic equation. I can't think of anything that multiplies to 5 and adds to 2 off the top of my head. So what I'm going to do is use quadratic equation, where we know it's minus 2 plus or minus the square root of b squared, which is 4, minus 4 times 1 times 5, divided by 2 times 1. So this is going to be minus 2 over 2 plus or minus the square root of 4 minus 16 is or 4 minus 20 is minus 16. And now we have minus 1 plus or minus, this becomes 4i. Then it's 4i divided by 2, which is 2i. So the roots, our solutions with r, are minus 1 plus or minus 2i. Perfect, we found the roots, but we want to find this general solution, our general equation. And what we're going to do is we're going to go to the FE handbook. This is not it. We're going to go up to, what was this? Sorry, I guess I can look up underdamped. Hopefully it comes up. I don't remember the exact page that this stuff is on. I know it's higher though. It should be towards the top in the ordinary, the ODE parts. And this is important that you know which sections of the book you're supposed to be looking. And here we are. Okay, so what do we notice here? Well, we notice, what does it mean to be underdamped? And I'm gonna erase some of this stuff. It means underdamped, and it means that we have complex solutions. A squared is less than 4b. We have complex solutions, meaning it's underdamped. So what we have is a general solution of this form. So I'll write that down over here. Y of t is equal to e to the minus alpha t c1 cosine beta t plus c2 sine beta t. Okay, but what is alpha and what is beta? Well, alpha is equal to this value, then really the negative of that value, which is going to be 1. Beta is going to be equal to whatever the imaginary portion is. This is going to be equal to 2. So now we've solved for the roots, and this is why we solve for the roots, so we can get a very easy plug and chug. That means y of t is equal to e to the minus alpha is 1, so we leave that there as 1, t c1 cosine of what is beta? Well, that's 2, sorry, not 3. 2t plus c2 sine of 2t. And that is going to be our answer. The reason this is underdamped, if you didn't notice before, it is because our roots are complex. A squared is less than 4b. In our case, it's going to be b squared is less than 4c. Because the way I do this is, or at least, a is, this is, sorry, this is A, this is B, and this is C. They say because A is always 1, they just let this be A and this is B. You can go whatever kind of convention you want to do, as long as you know what you're doing. That doesn't matter. Okay. All right. So now the next problem, it says find the Laplace transform. So we want to find the Laplace transform of e to the minus 2t cosine of 3t. Okay. Okay, so how do we do this? How do we find the Laplace transform of some function? Well, this is where you will go to your FE handbook. And again, this is a computer-based test. So you'll be able to do this. We'll press find and find the Laplace transform pairs. And of course here I already have this circled. So we have e to the minus alpha t beta t, and that's the form that we have here. E to the alpha t cosine beta t. So alpha's 2, beta's 3. Okay? And now the equation that we have is this becomes s plus alpha divided by s plus alpha squared plus beta squared. Okay, so this is a very easy plug and chug. A lot of the times it won't be this easy, but for the FE exam, you'll notice the questions sometimes aren't too difficult. They're not as hard as, the ones we might have been given in class. This is because they just want to make sure you have a very basic and good understanding of what you've been doing. That doesn't mean they're not going to give you hard questions. That means the questions you might get aren't going to be as difficult as you might initially think. Don't get me wrong, the exam is going to be very, very hard, but it's because there's so much information on this exam that this covers the entire 4 years that you've been in class. So it's just a lot of information all at one time. And sometimes that's a little overwhelming, and you might miss some questions that are very easy. That doesn't mean, give up and don't try. That just means you have to try a little bit harder to be able to pass. And this isn't something you're going to be graded on like you get an A or a B. It's either pass or fail. Anyways, this is the solution I got. This is the Laplace transform of this function. All right, and this last one, we have to find the Fourier transform of f of t, or e to the negative t for t is greater than 0. Another way we can say this is e to the negative t, absolute value, because t is greater than equal to 0, right? You can't have anything less than t. Okay, so the same thing you're going to do here. What you're going to do is you're going to look up Fourier, if I can spell it here. Okay, then you just wait until, your computer finds it in the page. And this might not be it. This is in heat transfer, so this probably isn't going to be it. And scroll down. Okay, this might be it here. We're scrolling down. It might be up, actually. Functions. Is it up here? Okay, well, it's not done. It's not up here. Let's keep scrolling down. Maybe it's further down. Okay, it definitely was not further down. I gotta find the table here. Oh, there it is. Okay, perfect. All right, so they actually give you a lot of transform theorems, which is really, really nice. Convolution, differentiation, integration. This is very important when you deal with inductors and circuits. You want to find the Fourier transform of this, but we're not here for this. We're here for this here. We're trying to find it of the form. What's the form? E to the negative t. Well, right away I see this, but we don't really have a u of t. So we can't do that. What I see is right here, e to the negative alpha t. That's nice. So what do we have? Well, e to the negative alpha t, or a of t. What is a? Well, a seems to be 1 for us, right? We have e to the negative t. So a is equal to 1. Well, that means we have it in the form of 2a over a squared plus 2 pi f. And this part is squared. So if a is 1, we just have 2 over 1 plus, what is this, 4 pi squared f squared, right? All right, yeah. So that's going to be it. And we have to notify that a has to be greater than 0, which a is 1, so it works out. So that would be our answer for this one also. So we take the Fourier transform, of e to the negative t. And the reason we use this equation and not the one above, we notice how it has a u of t. We don't have this u of t, so we can't necessarily say it is this equation we've been given. So we're going to be using this. All right, that should be good here. All right, so hopefully this made sense, y'all. And if you have any questions, of course, make sure to ask on any of these questions. If you want me to do a particular question, make sure to ask it in the comments, and I'll get back to you, and I'll probably make a video probably the next day, if not that day. So, but yeah, if y'all enjoyed, make sure, reach out to me if y'all have any questions or anything. All right, but thank y'all.